the questions as they come. Okay, so let's talk about the approach section of your proposal. So let's kind of back up a little bit and talk about the sections of your proposal. And you can see we're making pretty good progress to put those sections together. You have a draft of an abstract, a draft of an aims page. For your bigger research strategy part of the proposal, you've written your background and significance section now with figures. That was your assignment for today. Our next section, and this is probably the largest section of your proposal, is the approach section. Note that we will talk about the innovation and the future directions sections as our next class next week. So today we are going to highlight the approach section. And so what I hope to do in this first part of the class is to talk about what's in an approach section. We'll break down one of those examples from NIH on the approach section from those examples. And then I'll give you some pointers as you start writing your own. And then, you know, because this is the longest section of the proposal, you know, it's going to probably be at least 5 pages. You know, we'll talk about kind of how to pace yourself to get this to work in the time frame. But remember, you're just getting a draft here. Okay, so first let's start off with the definition of the approach section from the NIH. So I'll read this to you. Describe the, so the approach section, excuse me, the approach section will describe the overall strategy and methodology and analysis to be used to accomplish the specific aims of the project. Describe plans to address weaknesses in the rigor of prior research that serves as the key support for the proposal. So kind of how you'll improve on past research if it's appropriate. Describe the experimental design and methods proposed and how they will achieve robust and unbiased results. Okay, so this is basically how you're going to, the experimental methods you're going to use, the experiments you will run to, in each of your aims, so each of your mini goals. We'll also talk about this. You want to also discuss the potential problems, alternative strategies, and benchmarks for success to achieve the aims. So if you kind of take that together, what I typically see in an approach section for NIH are these 4 sections. So let's go through each of them. The first section of, and by the way, these sections, these 4 subsections are for each aim. So for each aim, you will have these 4 subsections. If you're doing 2 aims, you'll have 2 sets of 4 or 8. Okay. So the first section is something we call the rationale. Some people call it a justification. Some people even call it background. But the point of this rationale, like what I like to call a rationale section, is that you describe the logical basis for the short-term goal that's in that aim, the logical basis for your experiments you've chosen to do, the logical basis for the methods, and any prior literature that supports the strategy you're taking. So this is fundamentally different than the background that's in your background and significance section, because all of this information is about the methods and the goal in this aim. It's more specialized. The background information provided here should be distinct from the background of the significance section by focusing on the reasons for the short-term goal in the aim, not the larger long-term goal in the full project. So you may find, now that we're getting into the approach section, that there might have been pieces of this rationale that you put into your background and significance section, not realizing that you would be providing some background for each aim. So if it's appropriate, if you go back to your background and significance sections and you realize that you were sort of justifying the methods that you were choosing, talking about the prior literature that you have based your methods and your experimental design on, you might want to pull those out of your background and significance section and put them into this rationale section. Okay, it's no problem. Remember, these are all just first drafts, and we can reorganize and modify and rewrite and rewrite and rewrite as much as we want. Okay. If this is still not clear to you what the rationale section is, don't worry. We're going to go through in detail one of the proposals that the NIH provides as an example, so you can see sort of what they thought of as a rationale. The second part, subpart of each aim should be preliminary results. You will not have preliminary results. The only people who could maybe have preliminary results are people who are doing some kind of computational modeling or something like that. But in general, with this independent proposal for your candidacy exam, there is no expectation of preliminary results. So you can basically remove this preliminary results from one of the one of the sections you need in your aim. But for your prospectus, which we will talk about at the end of this class, there will be results that you will have obtained before your candidacy exam, and you will put them in this section. So this section will discuss each experiment that you performed, and you can put this into separate, kind of even more subsections. Each experiment to show the feasibility of your approach. Everybody who puts in preliminary results is really just showing, hey, I can do this. I can show that my methods are working, or I can show that my first experiment is working. Okay, so preliminary results are there for feasibility. Okay. Again, for your independent proposal that we are working on right now, you can just eliminate this section. You do not need it. So the second section you'll put in your independent proposal is this number 3, proposed experiments. Everybody's going to have proposed experiments. These are the experiments you will run to address the goal that you've outlined in the aim, okay? So my recommendation is for each experiment, you provide a separate subsection. So each proposed experiment will have its own little subsection. And in that subsection, for each experiment, you'll provide the goal, the experimental setup, any expected results, and then you're going to interpret that and put that into the context of the full aim. So if you need to transition to the next experiment, that would be the place to do it at the end. How many proposed experiments will you need for your aim? That is up to you. That is up to the goal, right? But I would say you're probably going to have at least 2, maybe up to 5 of these kind of individual experimental sections. Sometimes the experiment will not actually be an assay. It'll be more like a synthesis. That's fine. But each of these subsections should have a distinct goal on how you're going to achieve the aim, the goals of that aim. Okay, so that's the third section, which really will be the second for you. You only need 3 of these, the rationale, proposed experiments, and then this last one, which is the pitfalls and alternative approaches. And this section is very, very common in all grant proposals. Actually, I have a question here. So a question for Marcos: what happens if we have preliminary results from the literature? Does it look good to include them since they are not your results? So that's a great question, and I appreciate you asking that. Anybody else's preliminary results that are published are considered background. Preliminary results are unpublished results. So if you have results that are from a publication that really provide the feasibility basis for your methods, those go in the rationale section. Does that make sense? Okay, so any kind of literature precedent for what you're doing is considered the rationale. Preliminary results then would be something unpublished that you provide to the document. And again, there is no expectation you would have this for your independent proposal. Okay, great question. Thank you for that. So let's move on to the last section here, which is called pitfalls and alternative approaches. So what you want to do is, considering your proposed experiments, as you're writing those proposed experiments, you want to anticipate any possible challenges that you could have in those experiments. What if they don't go right? What if you can't use that method? What if you use the method and the results aren't what you expected? What would you do in that case? And so what this section does, this pitfalls and alternative approaches does, is it shows that you are thinking about all the possible problems, and you would tell us that you know how to fix them. So this section is really to help us see that you're thinking deeply about the project, and that no matter what the problem is, you will fix it. Okay, so giving us a few examples of what problems you anticipate and how you would overcome those problems, That's the point of this section. Okay. So these are so you're going to have 3 of these sections: the rationale, the proposed experiments, and the pitfalls and alternative approaches. Great. I have another question from Yannick. For the expected results, do we give just sentences or do we give graphs and sketches to demonstrate results? Great question. I would say if it's appropriate, like for example, if you're expecting to get very complicated data that would need some kind of analysis, you would be welcome to provide kind of theoretical results in a form of a graph or a picture. But I'd say in general, if it's not complicated data, you would be welcome to just discuss it in the text. I'd say oftentimes the approach section does not have as many figures as the background section, but you would be welcome to create a figure that would show how you would interpret a complex data set if it's appropriate for your proposal. Okay. So it keeps the questions coming. Okay, so now that you know the 3 sections, let's look at what your overall proposal should look like. Because now you guys should really have now, your proposal is starting to take shape. So what I wanted to do is just take a pause and say that you want to now start putting all of this writing you've been doing into the context of the bigger proposal. And I would highly recommend that you use headings and numbering to kind of keep everything organized. So when you go into your candidacy exam and somebody wants to ask you a question, they can say, oh, go to section X or go to section 3.2, you know, so that I can easily get to the information. So here's what I do for my proposals. There's many, many ways to do this that are all correct, but I'm just giving you my suggestion. I can give you his. I'm sure he probably does it a little differently. But what I do is I do Roman numerals for my background, my innovation, my approach, and my significant outcome and future direction sections. Then within those sections, I will add my A, B, C subheadings. So for example, in your background and significance sections, you had subheadings in that background and significance section. I put introductory topic because it's going to be whatever topic you have in your background section. You would make those each a section. The innovation section is basically like 1 paragraph, so we don't need subheadings. For the approach now, in the approach, you're going to separate your specific aims into 1 subsection specific aim 1 and 1 subsection specific aim 2 with the titles, the same titles that you have in your aims page. So if you change the titles of the aims, no problem. Just make sure you change them in both places. And then you're going to have subsections that are the ones that we just talked about. A rationale section. Again, you will not need a preliminary results section. This would be for your prospectus, not for this independent proposal. But you will have a proposed experiments with each of the proposed experiments in its own subheading. You can see that I have 3A, 3A as my proposed 1, 3A, 3B is 2, but you can use any number you want. And then finally, you end that aim with the pitfalls and alternative strategies. And you can see I replicated that same format here for aim 2, rationale, preliminary results, proposed experiments, pitfalls, and alternative approaches. We end with our future directions. Okay. So that hopefully gives you an idea of sort of what your whole proposal should be looking like. Okay. Now what I want to do is spend a few minutes to talk about what an example proposal from the NIH. And you know that we've been using these proposals from the National Institute of Allergy and Infectious Disease, and here is the web link. I'm going to be picking on 2 proposals here. One is Fabian, and then Gordon is the next one I'll talk about. So I just wanted to show you their outline. So we just talked about the outline of your approach section, where we'll have our rationale, proposed experiments, so on. I wanted to show you what a real proposal might have in terms of those sections. So in this proposal by Fabian, you can see they have an approach number. In this case, they didn't really number until they got to the subheadings within the research design here. But they have their aim number, they have their title, a pretty long title. In this case, they have what they called an introduction. What I called a rationale, they call an introduction. They also had a justification, feasibility, and a preliminary results section. And so what we'll talk, so what I'm assuming is that they sort of mingle the introduction, justification, and feasibility. All that would be probably considered the rationale section. for their proposal, with preliminary data kind of being mingled in there. So sorry that my phone is going off, I apologize. Anyway, so those would be kind of the rationale section. This one is, this second section is their research design. Instead of calling it proposed experiments, they called it research design. You can call it whatever you want to. I tend to call it proposed experiments. And you can see within the research design or the proposed experiments, they have one experiment, which is the biochemical approach, another series of experiments which targets the functional relevance, and here are 2 assays they're going to use. And then the functional relevance in cells, and they're using these 2 assays. So you can see that they have a very nice outline of the experiments they're proposing to do in this aim. And then finally, they have a section at the end called anticipated results, potential pitfalls, and alternative approaches, which is essentially very similar to what we talked about, is that pitfalls and approach and alternative approach sections. Okay. Let's look at the other proposal. You'll see it's really quite similar. These 2 seem to like the same type of format. They have their approach heading, specific aim 1 with their title. This is a little bit shorter title. I like that. Introduction, justification, and feasibility. This is really, again, these 2 sections are kind of mingling the rationale. In this case, under justification and feasibility, they have a review of the relevant literature. Again, that's going to be the rationale. And they also have their preliminary data in 2 separate kind of subsections. You can see here that they have a research design section, which we could also call proposed experiments. And they call these activities. You can do that if you like, where these 2 activities are actually kind of bigger goals with several different experiments kind of written within them. And we're actually going to spend some time going through this Gordon proposal here. So I'll give you some idea of how they organize theirs. Finally, they have a separate kind of very short paragraph on expected outcomes, and then the potential pitfalls and alternative strategies section. So you can see that these funded and example proposals have the very same format that we're talking about. Okay. All right, so let's kind of go a little bit deeper into these sections, because I know what you're thinking is, okay, I got to do these sections, but what's in them? Give me some examples. So I thought we would go through the each of these sections, each of the 3 sections you're going to put in your proposal: the rationale, proposed experiments, and the pitfalls. We'll do each of those and go into a little more detail. So this is taken from the Gordon proposal, and I copied it here. But in the interest of time, because I've already been talking for a while, I'm just going to kind of break down what's in this for you instead of having us try to read through it. You can see it's very long. So what's in this introduction section? What's in this justification and feasibility section? So I basically color-coded here so that we can go through and understand what they're putting in here pretty quickly. This introduction section is really, I guess my reading of it is it's sort of a reiteration, kind of a reinforcement of the objectives and hypothesis statements that they had in their aims page. They just want to remind the reader what the goal is of the proposal and this aim. So this is probably, this introduction, given its length, is probably a lot more detailed than what was in the aims page, but it's basically building off of that aims page. I honestly integrate this type of information into my bigger rationale section, but you see in this case, they made an introduction where they kind of talk about sort of the global approach of that aim, what's the objective of the aim, what's the hypothesis for the aim, what's the approach of the aim. And then they go into justification and feasibility. And in this case, they have a subsection that says review of the literature. And what you can see if you look in this review of the literature section is that they really kind of, just like we see in our sections of a proposal, they kind of start with the bigger picture. Here's my objective, here's my hypothesis. And then they go into the literature, drilling down before emerging again at the end to talk about the goal, the bigger goal statement. So for example, this first little mini paragraph, they talk about recent advances. They talk about some data from those papers. And then they end by saying, it's reasonable for us to study this P. aeruginosa infection as a way to understand biofilm infection. So they basically say, okay, here's my paragraph justifying my model organism. Next paragraph, they say a lot's been done with this model organism in the context of cystic fibrosis. FCF stands for cystic fibrosis. So in the second paragraph, they're drilling down a little deeper saying, in this aim, we're going to use this model organism, and we're going to use it as a model of cystic fibrosis, which is, of course, a big problem in human health. We will use this CF lung infection as a test case. We'll characterize the adaptation of this cystic fibrosis infection. So they're basically justifying how this model is going to be good for cystic fibrosis. Then what you can see in this next paragraph, they switch to a different topic, which is what the variables are going to be in this aim. So they're going to be using this model organism to look at cystic fibrosis, and they're going to be varying the polysaccharides and extracellular DNA that could possibly affect the biofilm they're looking at. So this third paragraph is just talking about the variables that they're interested in studying to try to achieve the goal of the aim. So if you have different catalysts or ligands or conditions that that you are wanting to discuss, to look through it, to study in this aim, you could put it in the rationale. And then finally, notice that at this last section, they really come back to what they talked about in the introduction, which is kind of what their global kind of hypothesis is and how this aim is going to answer that hypothesis. Okay, so I had a question, and that is, what's the difference between this section and the background section? I think you mean the background and significance section that you've already you've already created. Yeah, so my feeling is that the difference between this section, this rationale in your aim, and the background and significance is that the rationale here is specifically about the methods, the different molecules you're going to look at, the different experiments you're going to do. You're going to rationalize why those experiments and those approaches are right for this aim. The background and significance section, on the other hand, is really trying to talk about the bigger goal of the project. What's the bigger background? What's the human condition or the disease state or the kind of technical problem, the human condition problem you're going to solve, and sort of giving rationale to that. Here, you're giving rationale to the method and the goal in this aim. Does that make sense? Okay, well, keep asking me questions about that if I haven't gotten through, but you can see from this example that they are justifying the experiments they're doing in this aim. Why are we using the model organism? Why are we using it to look at cystic fibrosis? What are the parameters that we're changing when we do our methods, when we do our experiments, so that we can try to figure out what's going on in biofilms? And then finally, with all of that put in, rationalized, they can say, this is now what we can now do these experiments to understand the mechanics of biofilm formation. So yours will be kind of similar in the kind of format. Drill down. Why did I pick the methods? What are the variables I'm going to be changing in my experimental section? And how can I rationalize that those are the right things to be changing and my methods are the right ones to pick using this rationale section? Okay. All right, so that's rationale. Let's move on and talk about the approach. The proposed experiments. So my advice here is for each and every proposed experiment that you would like to discuss, that you have these three things. You need a goal statement. What is the goal of that experiment? Or if you have kind of a series of experiments that you're going to kind of push together, kind of crunch together, maybe you're going to look at one parameter with two different assays. Just to show reproducibility, which we'll talk about reproducibility in a bit. But you want to have a goal for that experiment. What is the goal? Why are you doing this experiment? What are you going to learn? The second, and this is probably the longest part of each experiment, is you need to set up that experiment. What reagents are you going to use? What equipment are you going to use? What data are you going to collect? And then finally, once you've explained the experiment, you need to talk about what the expected outcome of that experiment. What data are you expecting to see? What results would give you a positive or a successful outcome? Okay. So for example, if you are trying to optimize a catalysis, a reaction, what would be success there? How good a reaction do you need? What kind of yield? What kind of conversion? Whatever your parameter is, you need to talk about a success, okay? So in that context, let's look at this Gordon application to kind of break it down. I'm giving it to you here without highlighting, so you can go back to this after our class and read it. But here's my highlighting, so you can really see how for each experiment, they really break down the writing into this goals, experimental setup, and outcome statement. So let's jump here to activity 1 here at the bottom. Activity 1 is their experiment. And what they do is they start off with the experiment with their goal statement. We're going to determine the structures of, you know, their system, okay? And then what you can see is they jump right into how they're going to do it. What's their setup? What are they going to do? What are the methods, the reagents, the instruments? We will use confocal microscopy. There's their instrument. We will use quantitative image analysis. That's the data analysis they're going to use. We will determine the distribution size. So once they have the data, they're going to analyze the data for size. We'll also measure blah, blah, blah. Okay, so they're saying very clearly what they're doing. And notice, this is all in the future verb tense. They're going to be doing this in the future because they're proposing to do these experiments that have not yet ever been done yet before. Okay, so that's the experimental setup. What instruments, what methods, what data will you collect, and how will you analyze the data? Next, the last section is the outcomes. So you can see, we expect this size distribution to be something like that, something, we expect the width to be X, we expect that if. So they're basically saying our expectation is that we will see these kinds of results. And again, if you are doing an experiment that's quantitative and will give a certain number, like a yield or a conversion or a potency value, you should give a specific parameter of success. We need to achieve greater than 80% yield to call it a success. Okay, all right, does that make sense? Okay, so for each and every experiment, you're going to do this kind of format. Notice in this proposal, they also have a methodology section that kind of precedes all their experiments. And I think this could be very nice if you have very complicated methods that maybe need some explaining to your committee members. In this case, the reason that they do it is because they have an animal model. And animal models have a lot of parameters. If you're not using animal models, you may not need this section. I've never put in a methodology section like this. But if you think it would be really helpful to very clearly articulate to your committee what your methods are, I think that would be great, okay? All right, let's end then by talking about the potential pitfalls section. And so in this case, we see that tends to be kind of if-then statements. If this goes wrong, then I'll fix it by doing this, okay? So that's, you can see that in their potential pitfalls and alternative strategy section. If we measure changes, blah, then we will investigate something else. And we will also investigate, you can see they also go on, we will also investigate something else. So they're giving you a scenario that they anticipate could be sort of an unanticipated or unexpected scenario, and talking about how they would work their way through that. Okay, unexpected results can be amazing and really helpful. You just have to know how to work through them, and that's what we're doing here. So this section is really great for showing your nimbleness to get through any problem. I also want to point out that in this particular proposal, they also have a very, very short 2-sentence expected outcome, just maybe to give continuity to the aims. Like this aim will do this, and now the next aim is going to answer another question. So that can add, if you find that that would be really helpful, you can add one of those continuity sections. I have a question. Let's see. It says, can the approach section have figures? Oh, absolutely. I would say good figures. One option for a figure would be to anticipate, like again, complex data sets that you have to do a lot of data manipulation. You could give a theoretical analysis of the data. I don't see that often in NIH study sections, but in your case, because you guys are new to this and kind of have to prove that you know how to do the data analysis, I think that would be fine. But I think more common is I always see pictures or figures in the rationale section, because maybe you want to show a synthetic scheme or maybe a structure, or maybe we don't generally put other people's data, so we don't usually do that, but you can maybe show a table of other people's data. So I would say it's very common to have a figure or two in the rationale section, maybe a little less common in the proposed experiment section. But again, it would be appropriate in the proposed experiment section if you want to kind of show proposed data, show theoretical data, or maybe show the workflow of how you would analyze the data. That's also very common, especially if like you're developing an inhibitor and you have like 6 different ways you're going to analyze that inhibitor. You could show like a workflow with arrows showing each assay or something. Anyway, think about what would be really helpful visually for your audience, and that's what I would do. Absolutely, make a figure if you think it would. Remember, a figure can mean 1,000 words, so please feel free to use a figure. Okay, I need to finish up. So let me, so that's kind of my drilling down of these proposals. Hopefully you have a very clear idea now what you want to do. Let's kind of finish up here by talking about something that's very important in science, and it's particularly highlighted by the NIH. So I thought I'd point it out here. And that is the concept of rigor and reproducibility. So rigor and reproducibility in all of our science is very important. And so I think as you develop your methods and you think about your data analysis, you really want to be thinking of these concepts of rigor and reproducibility. Okay, so what is rigor? Scientific rigor is a strict application of scientific method to ensure unbiased and well-controlled experimental design, methodology, analysis, interpretation, and reporting of results. And this definition is taken directly from this website on reproducibility from the NIH. So I should probably have that in quotes. That is directly the definition from NIH. So what does that mean to you as you're writing your approach section? As you write your approach section, discuss how the experimental design and methods will achieve robust and unbiased results. So how will you ensure that what you're doing is the best experiment and it's not going to be influenced by your design, your methods? You have an experimental design and setup that's going to give you whatever result happens to happen. You know, there's no bias there. This is pretty easy in chemistry. Rigor can be very tricky when it comes to mouse models and humans. But when it comes to our experiments, you know, when you run the reaction, you get a result. It's not too hard to interpret that. So don't get too caught up in this, but make sure that your methods are precedented, that that you have really thought about any controls you need to do. Maybe do a reaction without catalyst to make sure that the catalyst is having the effect that you think it is. So that's kind of what rigor looks like. Reproducibility is now about the being able to replicate the results. I actually made up this definition. This is not NIH definition. This is Mary Kay Pflum's definition. And that definition is scientific reproducibility is the use of multiple independent trials to assure that results are repeatable despite technical variables. And the technical variables that I can think of that I would be worried about are different batches of reagent, different days of the week, maybe nighttime versus daytime, maybe summertime versus wintertime, and even different researchers. So these kind of variables you want to include in any kind of error analysis you would have in your data. Make sure that you're really thinking about how reproducible, how easily you can repeat that experiment. So as you write your approach section, discuss how reproducibility will be achieved, including the number of trials, technical variables, and if appropriate, if you're actually you're generating a quantitative number, a yield, I don't know, an IC50, a potency, talk about your error analysis, okay? Okay, so that's rigor and reproducibility. Be sure that you're thinking about how well thought of these experiments are. Okay, let's end with just a few tips, and I'll go through these kind of quickly so we can get to the in-class activity. First of all, just like you did with your background and significance section, please, 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 please write an outline. And that outline can look very similar to what you saw in those example proposals that I talked about earlier. But put in your rationale, maybe think about what you put in the rationale. Write out the aim, the different experiments you'll use, so on. I would also highly recommend, if you haven't already, to just skim the example proposals and gain inspiration from them What information to put in your proposal? What is the format? What level of detail do they put in there? I mean, do you need temperatures and times? No, you don't need temperatures and times. What you need, and generally not concentrations either, you just need kind of general experimental setup so that we know that you know what your experiments will look like. So use those example proposals. Please skim them and learn from them, because you want yours to look similar to them. Mimicking in science is great. Just learn from others. Okay, we already talked about this last time, and that is that you want to try as best you can to have aims that are independent. They are not overlapping. I know that might be difficult, so I imagine that your committee might overlook dependence, but as best you can, try to make your aims independent. Okay, here's a few more. In general, each aim should be an overall goal or testable hypothesis that requires a series of experiments to be accomplished. So if you find that you're writing your approach and you only think of one experiment, then maybe you need to rethink that. If you're writing an aim and you only have one experiment, you might want to rethink maybe making that aim a little bit bigger. As we talked about earlier, the verb tense in the proposed experiment section is future tense. I will be performing. How many experiments should be in the aim? It's up to you. I mean, and how many do you need? I would say at least 2, although 2 seems kind of low to me. But it's really going to depend on your goal. So I would say, you know, think of this as kind of what would take you half time for 4 years to accomplish in one aim. So you're going to have 2 aims that's going to be accomplished in 4 years. So this would be half of that 4 years, and the other aim would be the other half of the 4 years. That's a lot of time, and it's going to probably need more than 2 experiments. As you write your experimental setup and expected results for each experiment, what could go wrong? How could you overcome that problem? Write these problems and solutions down, and you can then just write little notes in your pitfalls section, and then you can address them later when you get to that section. You'll use references in the approach section just like you did in the background and significant sections, although probably not as many. The background and significant section probably has the most references. And please realize that this approach section is probably going to be the longest section of your proposal. I'd say at least 5 pages. A question that just came up is, what should we use, I or we? This is a hard one. I guess I would use we, even though this is your idea. I think for this exercise, you can use either one, but I don't know. I still think it's weird to use the word I. So anyway, I don't know. Ed, do you have an opinion on that?
I would use we simply because, you know, we always work in teams. I mean,
I don't know. I just think it sounds strange to say I, like you're this independent. I mean, science is collaborative. So yeah. Anyway, I guess my advice is to use we, but nobody's going to have a problem if you use I. It's just, I think the faculty will probably say, oh, that sounds strange, but they won't penalize you. Okay, let's end by talking about your homework assignment for next time. We understand that this approach section is a large writing assignment, and based on the feedback we got from you on the background section, which of course was a huge writing assignment, we're going to give you a little bit more time for this section. So we would like for you to give us the first draft of this approach section on Tuesday, the June 16th, at basically right before midnight. So that gives you an extra full day, more than a full day, to finish this this section. We don't want to give you until the next class period, because you have more writing you have to do for the next class period, but we want to give you enough time that at least you can get that first draft, okay? Remember, folks, this first draft doesn't have to be perfect. You just want to get all your ideas down, and then we have lots of time before your candidacy exam to rewrite and rewrite and rewrite. Okay, so by Tuesday, June 16th at midnight, write a NIH style approach section. Please realize, though, you're still going to be talking about this approach section in your peer mentor breakout session on Monday night. So have something written, maybe have a good amount written so that you could discuss it with your peer mentor section. Maybe they can give you feedback. So before that Tuesday, June 16th deadline, you can really make that approach section even better than it would have been if it had been due on Monday. Okay, I'm sorry that took so long, but we had a lot to cover there. I hope that's clear. And with that, I will hand the mic over to